Yeah, whichever come first. Blessings on blessings on blessings. Look at my life, man, that's lessons on lessons on lessons. I treat the beat like it's a reverend. I tell the truth like, Father, forgive me. These are all my confessions, man. This wasn't luck, it was destined. I done lost homies who been with me since Ed and Eddie, who flip like confetti. And then when you back, they back to call you dog. That shit can get petty. Bitch, don't get no dap to me, nigga. Funny thing about talking behind my back is that it just keep coming back to me, nigga.
So this is our first example of integration by parts. We want to integrate 3x cosine 4 minus x dx. This is an indefinite integral, so we're gonna have a plus c at the end. And let's look at what kind of case we have. We had 3 cases in the last video. So we have 3x multiplied by cosine 4 minus x. So this falls into our first category from last time, polynomial and trig function. And we're going to make our u the polynomial and our dv the trig function. And since we have our polynomials to the first degree, we have 3x, x to the first power. We're only going to have to use integration by parts once. So let's make our u equal 3x, our dv equal cosine 4 minus x dx. Don't forget the dx here. If you ever see a d on one side of an equation, there has to be a differential d on the other side. So to get to du, we just differentiate, and it's going to be 3 dx. Again, you see a du on this side, we have a dx on this side. And v, to get from dv to v, we're just going to integrate both sides. Integral of dv is just v. So whatever v is, it's going to be the integral of cosine 4 minus x dx. And I'm just going to get rid of this so you still see that. And I did that out before the video started because it's more of a substitution rule example. We just cosine 4 minus x is a function within a function. The inner function is w. We don't use u because we're using it for integration by parts. W is 4 minus x, dw is negative dx. Substitute in the w for 4 minus x. Replace dx with negative dw. Integral of cosine w dw is sine w minus sine plus c. And then put 4 minus x back in for w, and we see our integral is negative sine 4 minus x plus c. Now, when we actually put in our v, we don't need a plus c because we worry about the constant of integration at the end, just to simplify things. So our v is negative sine 4 minus x. So the integration by parts formula tells us that since this is integral of u dv, it's going to equal u times v minus the integral of v du. Now u is 3x, v is negative sine 4 minus x minus the integral of v, which is negative sine 4 minus x du, which was 3 dx. And we're going to simplify this, pull a minus sign on the outside, we get minus 3x sine 4 minus x. These two minus signs will combine to a plus sign. Pull this 3 out, we have the integral of sine 4 minus x dx. And now, this is just a u substitution problem. We already used u, we already used w, let's just use z. So z is 4 minus x, dz is negative dx. So we'll just do the integral off to the side actually, so we don't need to keep rewriting things. Integral of sine 4 minus x dx is and I'm kind of going through this. If you need help on this, go look up your substitution rule again. we have cosine 4 minus x plus c. And our final answer is 3x sine 4 minus x plus 3 cosine 4 minus x. And even though we have, it should be 3 times c, c is just some arbitrary constant. 3 times any arbitrary constant is still going to be some sort of arbitrary constant. So let's just call the whole thing c. And that is our answer.
Straight up.
Way up, I feel blessed. I ain't gonna say that we back or nothing, cause that implies that we're back from something. If we're back from something, it's some checks you owe us. I expect that payment, nothing less or over. I don't need them favors that you asked me for. I could give.
So this is example 2 of integration by parts. And if we look at the cases, well, let's see what we're integrating first. We're integrating 2x squared e to the negative x dx. So this is again case 1. We have a polynomial and an exponential function. So our u is going to be a polynomial function, our dv is going to be our exponential function. And since we have x squared, this is degree 2, we're going to have to use integration by parts twice. So let's get at it. This is going to be our u, it's the polynomial function. And this is going to be our dv. So u equals 2x squared. And since we're going to do this twice, let's call this u1, dv1. So u1 equals 2x squared, dv1 equals e to the negative x dx. Don't forget the dx. So du1 is 4x dx. And let's put a line here to differentiate everything. V is just going to be the integral of negative x e to the negative x dx. This is a quick substitution. I'll do it out here really quick. So we have negative e to the negative x. We don't need the plus c because we're going to do it at the end. So our integral is, since this is u, integral of u dv, this is going to be equal to u1 v1 minus the integral of v1 du1. u1 is 2x squared. v1 is negative e to the negative x. And we're going to subtract that from the integral of v1, so negative e to the negative x du1, which is 4x dx. Simplify this, pull the minus out, 2 negative 2x squared e to the negative x. These minus signs will combine. We have, and pull the 4 out, we have x e to the negative x dx. Sorry. And now we're going to have to define another u because we have another polynomial and trig function, or exponential function, sorry. So this will be our new u2, this will be our dv2, and it's actually the same as our dv1, e to the negative x. This is the case when we have exponential functions. They're going to keep repeating. So u2 equals x, du2 equals dx. Our dv2 is e to the negative x dx, and just like before, our v2 is just going to be negative e to the negative x, same thing as before, same integral. So this is all the same, and this is going to be on the inside u2 v2 because we have the integral of u2 dv2, so it's going to be equal by the integration by parts formula to u2 v2 minus the integral of v2 du2. You don't have to write this down every single time. You can just calculate this little integral off to the side if you want. I'll just write it again, just so we know the context. u2 is x, v2 is negative e to the negative x, and this is minus the integral of v2, which is negative e to the negative x, and our du2, dx. And this is all in parentheses. Maybe you want to use brackets to emphasize that. So you have negative 2x squared e to the negative x plus 4. We'll simplify the inside of this. Negative x e to the negative x. Use minus signs. We'll combine to a plus sign. You have e to the negative x dx. And then we'll distribute this 4, so we don't need to keep writing these big brackets. So minus 4x e to the negative x plus 4 integral of e to the negative x dx. And this is the same integral we had all the way up here. Integral of e to the negative x is just negative e to the negative x. So we just rewrite this, and this is negative e to the negative x. We're going to have a plus c out here. We can just put the minus on the outside, and this is our answer.
Be quiet, I'm doing a toast. For niggas that don't really do shit, I swear y'all be doing the most. Stop worrying about whoever's next. I am just worried about my mama worrying less. I think I'm famous enough, I don't need any more press. I am convinced I'm the only one left.